Hello everyone, and thank you for joining us today in our live webinar. In this session, we will provide you technical insight and the guidance perspective to deploy HCL Commerce version 9 over OpenShift. My name is Kamran, and I'm working in the Royal Cyber as a technical lead of many services team. I'm your webinar speaker along with my colleague Daya Ahmed, our OpenShift Cloud Solution Admin. If you have any questions or have trouble in hearing or viewing the webinar at any point in time, please let us know in the questions window. You can also post your questions or any comments in the same window anytime during the presentation. We have a dedicated slot to answer all your questions towards the end of presentation. Before to proceed with the technical discussion, I would like to share some overview about the Royal Cyber. Royal Cyber is a globally recognized award-winning technology partner that is helping companies imaging, execute, and accelerate their digital transformation journey for the past 20 years. Royal Cyber provides superior solutions that create exceptional business value, guarantee success, and transform business with robust and adaptable digital solutions that satisfy today's needs and unlock tomorrow's opportunities. We have 10 plus offices operating globally in 5 continents. Also, we have 600 plus clients across the globe. This is our agenda, and we will see about these in today's session. Red Hat OpenShift overview, OpenShift architecture, OpenShift core components, HCL Commerce V9 overview, Helm architecture, deploying HCL Commerce version 9.1 on OpenShift cluster using Helm charts. And at the end, we will see CI/CD implementation and how it works in HCL Commerce version 9.1. Now, I would like to request my colleague Daya Ahmed to start with the technical deep dive about the Red Hat OpenShift. Hi there.
Thanks, Kamran. Hello, everyone. Today, I'm going to give you an overview about OpenShift. Let's have a quick introduction about deployment methods. In the traditional deployment, application will run directly on the physical servers, and you don't have a convenient way to define the resources boundaries for each applications. This may cause resources allocation issues. Of course, you have an option to run your applications, each application in a separate physical server. However, it's expensive for organizations to maintain many physical servers and manage many applications across these servers. Moving to virtualization. Virtualization allows you to run multiple virtual machines on a single physical host. This means that your application can be isolated in a different virtual machine. So you can define resources boundaries for each virtual machine. Of course, you have a level of security as each application completely isolated in a different virtual machine. And also you can present a set of physical servers as a cluster, virtualization cluster. So virtualization reduces the cost of hardware and reduces the cost of management. Moving to containerization, Linux containers use the concept of Linux namespaces to isolate the containers from each others. However, the containers still run on the same operating system and share the same kernel. So containers considered as lightweight compared with the virtual machines which have a full operating system. Using containers have many benefits. Less overhead, because it's a lightweight and use less resources compared with virtual machine. Also, it increases the portability as the containers can be deployed on a different environments. on a physical or a virtual or a cloud environment. And it also increases the consistent operations as it guarantees that the container will run the same regardless where they are deployed. Containers also accelerate the development process. Containers can be deployed on a single host, or it can be distributed and scaled across a cluster of hosts. Kubernetes is an open source system for automating deployment, scaling, and management for containerized applications across multiple nodes. Kubernetes mainly has two types of machines, control plane and worker nodes. Control plane nodes, which control and manage the work cluster, and the worker nodes will run your application workload. One of the key features of Kubernetes is the scalability, as your application can be scaled and distributed across multiple worker nodes. Also, Kubernetes has a service discovery and load balancing feature. Kubernetes will keep track your application's replica and load balance the traffic between them. Also, you can define the desired state for your application deployment, and Kubernetes will take care of achieving the desired state. And of course, you can easily roll back to the previous release. Kubernetes has a self-healing feature. So if your application failed, Kubernetes will automatically try to restart the failed application or a failed pod. Also, Kubernetes lets you to store and manage sensitive information such as password, tokens, and SSH keys in a Kubernetes secret. Moving to OpenShift, Red Hat OpenShift is an open source container application platform that runs on Red Hat Enterprise Linux Core OS and built on top of Kubernetes. It takes care of integrated scaling, monitoring, logging, and metering functions. It also gives organizations the ability to build and deploy and scale applications faster. OpenShift can be deployed on any physical, virtual, public, or private cloud, or even be deployed as a cloud managed service. And it runs on Red Hat Enterprise Linux Core OS and built on top of Kubernetes. OpenShift Kubernetes engine add a cluster services, contains automated operators, logging, monitoring, routers, and integrated registry. OpenShift Container Platform adds a platform services such as Service Mesh, CI/CD pipelines based on Tekton, and serverless. It also adds application services such as languages runtimes and databases. It's also add a developer services such as developer CLI, VS Code extensions, and IDE plugins. If you have a multiple OpenShift clusters, it can be managed through ACM. So you can through ACM deploy your applications across these clusters. Red Hat OpenShift gives you the flexibility to have a self-managed or fully managed OpenShift running on cloud or on-prem. Red Hat OpenShift offers a set of developer tools and multi-language support. OpenShift also offers over-the-air upgrades with one click. Also, if you have a multi-clusters, it can be managed through ACM. OpenShift comes with rich graphical user interface that have most of administrators and developer tasks. Red Hat OpenShift gives you the ability to monitor and collect logs of your application workload and for OpenShift itself. One of the most important features of OpenShift is advanced security, including role-based access control or PAC, security context constraints, SCC, and you have a certified and tested images from Red Hat or from its partners. And also, it's a straightforward to develop your applications by only pushing your code to SCM, and OpenShift will take care of building and deploying your images to OpenShift. OpenShift 4 comes with an easy way to deploy OpenShift IBI deployment method. It means that you only need to allow the installer to interact with your underlying infrastructure and provision all needed resources to deploy OpenShift. OpenShift architecture. OpenShift had three main node types: control plan nodes, worker nodes or application nodes, infrastructure nodes. The control plan nodes, which is responsible for managing and monitoring the whole cluster. It has three main components: API server, which is interface to OpenShift cluster. So any request to the cluster will go through the API server. Data store. OpenShift needs a data store to store all cluster information. OpenShift uses etcd, which is a key value store, to store all cluster information. Scheduler. Scheduler decides which nodes the pods will be provisioned on. You have a health scaling controllers, which monitor and check the status of the pods and nodes. The application nodes or worker nodes, these nodes will host your application workload. And as for infra nodes is a set of worker nodes labeled with a special infra label, and it will run OpenShift router, OpenShift integrated registry, OpenShift monitoring, and OpenShift logging. As we mentioned, OpenShift can be deployed over different infrastructure, on-prem or cloud. And also we have two main different deployment models. We have a self-managed model and we have a managed model. A self-managed model or a customer-managed model, you as a customer are responsible for managing and upgrading your OpenShift cluster. However, a managed OpenShift services, the Red Hat SREs or a cloud provider SREs will manage the cluster on behalf of you. So it's not your responsibility to manage or to take care of your cluster. So examples of vendor managed or a managed OpenShift cluster is Red Hat OpenShift Dedicated, which is managed by Red Hat, Amazon Red Hat OpenShift, which is ROSA, Azure Red Hat OpenShift, Red Hat OpenShift Dedicated, Red Hat OpenShift on IBM Cloud. As an example of customer managed, which is Red Hat OpenShift Container Platform, and also it can be deployed on premises or on any different cloud provider. The difference between self-managed OpenShift or managed OpenShift: a self-managed OpenShift, you as a customer responsible for deploying and managing and updating your OpenShift cluster. It can be deployed either on-prem or on the cloud. A managed OpenShift will be managed on behalf of the customer by Red Hat SRE or by the cloud provider SRE. You only have to pay just for your usage, either for a cloud provider resources or for Red Hat subscription. As an examples of managed OpenShift is OpenShift dedicated, Red Hat OpenShift service on AWS, Azure Red Hat OpenShift. As an example of managed OpenShift services, Rosa, Red Hat OpenShift service on AWS. As we can see here, you only need to enable OpenShift service from the AWS console, and you only need to run a simple command to provision the cluster, and that's it. I think I'm done.
Thanks there to provide us the great technical insights on OpenShift. In the next part, we will see how OpenShift features and Helm chart makes HCL Commerce deployment fast, simple, and in line with industry security standards. So let's start with the HCL Commerce version 9.1 overview. HCL Commerce is a high availability, high scalable, and customizable e-commerce platform able to support hundreds of thousands of transactions per day. HCL Commerce allows us to do business with consumers or directly with business. HCL Commerce uses cloud-friendly technology to make deployment and operation both easy and efficient. It provides easy-to-use tools for business users to centrally manage across the channel strategy. Business users can create and manage precise marketing campaigns, promotions, catalog, and merchandising across all sales channels. Busy users can also use AI-enabled content management capabilities. So, what is the new in HCL Commerce version 9? In the legacy version of HCL Commerce, like version 7 or version 8, we had a monolithic architecture, and HCL Commerce was deployed on a set of servers behind a load balancer. However, in HCL Commerce V9, we have a microservices architecture, which makes HCL Commerce deployment fast, easy to troubleshoot, and scale up the environment as per our needs. Also, in HCL Commerce V9, we don't have any more installation packages. Also, uh, it's provided as a Docker images. Code changes are also deployed as Docker images. And the main thing in HCL Commerce V9, the concept of instance is eliminated from the HCL Commerce version 9 deployment procedure. In HCL Commerce V9, the integration with tools like Jenkins to implement the CI/CD pipeline, adoption of lightweight IBM WebSphere Liberty, replacement of enterprise Java Beans with Java Persistent API, externalized customization programming model or RESTful API model, and implementation of the jQuery framework for Aurora Starter Store, the main features in HCL Commerce V9. HCL Commerce version 9 architecture depends on the microservices, and in the V9 we separate the platform into search, store, customization, and the core transaction server, which makes HCL Commerce environment independent, easy to deploy and troubleshoot. Transaction server is like a container service that runs transactional business logics in APIs that serve other commerce servers. And store server is also a container server that runs storefront for all the stores and holds all the storefront assets. Then we have search server, It's also a container server that provides the search engine capabilities for front-end application. And at the last, we have customization server uh, that runs custom business logics. In HCL Commerce V9, there is no any dependency on out-of-the-box Aurora store model to achieve success. When we talk about the HCL Commerce deployment of our OpenShift, then we have Helm. Helm is a Kubernetes deployment tool for automating creation, packaging, configuration, and deployment of application and services to Kubernetes or OpenShift clusters. Helm lifecycle management depends on create, install, update, delete, rollback, version status. And Helm allow us to easy installation and management of Kubernetes applications. Helm 3 is the latest version of the Helm. The main change in the Helm 3 version, it comes without tiller or server, and it is interacted directly with the Kubernetes API server to install, upgrade, query, and remove the Kubernetes resources. The main benefit of removing tiller is that security is now on a per user basis. It is delegated to Kubernetes user cluster security. Now we have Helm charts. By using the OpenShift features and Helm charts based technology, we make HCL Commerce V9 deployment simple and fast. Helm uses a packaging format called charts. A chart is a collection of files that describe a ready set of Kubernetes resources. A single chart might be used to deploy something simple like a memcache pod or something complex like a full web app stack with HTTP servers, databases, caches, and so on. Helm charts are like application deployment blueprints that containing Helm packages as a text file. So now we have HCL Commerce version 9.1 deployment of our OpenShift architecture. So in this architecture, we can see the web server is the first point of contact for incoming HTTP requests for our e-commerce application. In order to interface efficiently with the WebSphere application server, it uses the WebSphere application server plugin to manage the connection between the two components. The transaction server within the WebSphere application server, allowing it to take advantage of many of the features of the application server. The database server holds most of your application data, including product and consumer data. Before to proceed with the HCL Commerce version 9 deployment of our OpenShift, we have some prerequisites that we need to make sure that should be in place before the deployment. So first we have OpenShift cluster that should be up and running. Then we have Docker registry to push and pull the images from there. Either we may use internal OpenShift registry or we can use any cloud registry like ECR in Amazon. And the next we have Helm 3. So before the deployment, we need to make sure that we have Helm 3 should be installed and works. Create the namespaces for HCL Commerce deployment. Before to deploy HCL Commerce V9 stack over OpenShift, we needed to create the different namespaces or project to deploy the Vault and HCL Commerce application pods. A namespace is a Kubernetes concept that allow a virtual cluster within a cluster, which is useful for dividing the cluster into separate virtual clusters that each have their own access control and resources quota. Each HCL Commerce environment will be deployed under different namespaces or project, like dev, QA, staging, and production environments. And we may use the same environment names to create the projects. So now we have OC new project command. By using this command, we can create any specific project or any specific namespaces in which we can create the Vault and HCL Commerce version 9 stack over OpenShift. HCL provides us the direct link to download the desired V9 images. However, before to download the desired images, we need to make sure that we have valid and proper credentials to download these images from the HCL portal. Container registry to save the HCL images, that would be the important part when we deploy the HCL Commerce over OpenShift. To push and pull the HCL version 9 images, we have a container registry, and it can be any public or private that we may use, or either we can use the OpenShift internal registry to push the images. Security context constraints is the crucial part in the HCL Commerce deployment. Otherwise, application pods would not be up and running. Security context constraints can help you control what actions and access the pods in your container have, such as usage of privileged containers, root namespaces, host networking imports, volume types, host file systems, Linux permission, such as read-only or group IDs, and more. So we needed to make sure before the deployment that we assign the proper security context constraints to the service account. Service account provides a flexible way to control Kubernetes API access without sharing our regular user credentials. So instead of using any specific username, we can create the service account, and we may use this service account to create the application pods. After download the desired images from the HCL portal, then we can load and push these images into the registry. Then we need to make sure we have some necessary adjustment as per our environment needs into the Vault and HCL Commerce version 9.1 Helm charts according to our environment, like database host, configuration, images tag, etc. Once we will be good with the desired changes in the Helm charts, then we have a Helm install command to deploy and set up the HCL Commerce version 9 stack over OpenShift. After deploy the HCL Commerce version 9 stack, then we need to create the routes for the services only for versions 9.1, 6.0 and earlier version. Since latest version of HCL Commerce that starts from version 9.1.7.0 already supports OpenShift routes. OpenShift routes simply allow us to host the application at the public URL. By default, when we deploy the HCL Commerce version 9 over OpenShift, So Helm chart create the ingresses rules, and OpenShift will automatically create the equivalent routes from these rules. However, we need to configure the re-equip TLS termination. When we get the route, so here we needed to pass Vault CA certificate. So we can use CA as a destination CA in the OpenShift routes. Now we have Jenkins CI/CD for HCL Commerce version 9.1. The HCL Commerce V9 continuous integration delivery pipeline combines containerization, cloud service integration, and extensive customization since it uses loosely coupled open source tools. So the pipeline is highly flexible and customizable. When we are looking for our HCL Commerce build and deployment on a single click to continuous changes and improvements, then we have a CI/CD tool. To achieve continuous integration delivery with a comprehensive CI/CD strategy to run HCL Commerce build and deployments on a single click for continuous changes and improvement deployments. HCL CI/CD is also compatible with the traditional model of infrequent major releases, but even in such environments, it supports rapid fixes and continuous uptime. So now here we have a CI/CD flow that is showing once the developer creates the code in the development environment like HCL Commerce developer environment, then developer push their code to a source code repository like Git or Bitbucket. Then we have implementation scripts such as Python or Groovy scripts so that when code is integrated, the pipeline can automatically call the WCB utility to pull code from the source repository and build a customization package, and then push this package to an artifact repository. For example, you might want to use artifact repository like Nexus. Then we implement the scripts so that pipeline pulls the customization package from the repository and creates new Docker images and then push these images to a Docker repository. To create the new images, we have to define a Docker file. In this step, you may also use run engine commands to configure the application within the Docker images. For example, to configure the data source for the application to connect to your database. And then deployment manager may deploy the new changes in test and queue environments accordingly with the help of these Docker images. We may also run automatic unit tests or the functional test on the new environments before to proceed with the staging and production deployment. Once we will be good to create the Jenkins pipeline on the Jenkins server. So it should be like the same that we are showing in this slide. It started from checking the code and then creating WCB Commerce build, and then we have copying the package to deploy folder. After that, this package would be unpacking and then updating the images with the changes. After updating the images, there would be push to the repository and then our pods would be restarted with the new changes. Now our question answer window is open and you may post your questions or any comments in the same window. Thank you.